Hello guys, for this video, it's chapter 7, IP addressing summary. So, addressing is a critical function of a network layer protocols. Addressing enable data communication between hosts, regardless of whether the hosts are on the same network or on different networks. Both Internet Protocol version 4 or IPv4 and Internet Protocol version 6 or IPv6 provide hierarchical addressing for packets that carry data. It's composed of IP network, addresses, IPv6 network addresses, connectivity verification. So let's start with binary and decimal conversion. It's composed of IP version for addresses, positional notation, binary to decimal conversion, and decimal to binary conversion. IP version for addresses. Binary is a numbering system that consists of numbers 0 to 1, 0 and 1, called bits. In contrast, the decimal numbering system consists of 10 digits consisting of the numbers 0 to 9. Binary is important for us to understand because of host, server, and network device use binary addressing. Specifically, they use binary IP version for addresses to identify each other. Next one is the positional notation. Learning to convert binary to decimal requires an understanding of positional notation. Positional notation means the light represented the values represent the position. The digit occupies the sequence of numbers to already know the most common numbering system, the decimal base 10 notation system. The decimal positional notation system operates. So next one is the binary to decimal conversion. To convert the binary IP version 4 address to its dotted decimal equivalent, divide the IP version 4 address into 4 8-bit octets. Next, apply the binary position value to the first octet binary number and calculate accordingly. So the next one is decimal to binary conversion. It is also necessary to understand how to convert a dotted decimal IP version 4 address to binary. A useful tool is the binary positional value table. The following illustrates how to use the table to convert decimal to binary. So next one is the IPv4 address structure. It's composed of network and host portions, the subnet mask, logical and the prefix, logical A and D, the prefix length, network, host, and broadcast addresses. So network and host portion. Understanding binary notation is important when determining if two hosts are in the same network. Recall that an IP version 4 address is a hierarchical address that is made of a network portion and host portion. When determining the network portion versus the host portion, it is necessary to look at the 32-bit stream. Within the 32-bit stream, a portion of the bits identify the network and the portion of the bits identify the host as shown in figure 1. The subnet mask. When assigning an IP version 4 configuration to the host IP version 4 address, a unique IPv4 address of the host, a subnet mask used to identify the network host portion of the IP version 4 address, a default gateway identifies the local gateway, example local router interface IP version 4, to reach the remote network. So Next one is the logical AND. A logical AND is one of the three basic binary operations used in logical logic. The other two are OR and NOT. While all three are the same in data networks, only AND is only AND is used in determining the network address. Therefore, our discussion logical AND is the comparison of two bits that produce the result to identify the network address of an IP host. The IP version for address logically ANDed bit by bit, and the subnet mask ending between the address and the subnet mask yields to the network address. Next one is the prefix length. Expressing network address and the host addresses become dotted decimal subnet mask address can become cumbersome. Fortunately, there's an alternative shorthand method to identifying a subnet mask called the prefix length. Specifically, the prefix length is a number of bits set to 1 in the subnet mask is written in the slash rotation, which is a slash followed by a number of bits set to 1. Therefore, count the number of the bits in subnet mask and prepend it is a slash. It with a slash. So the next one is the network host, and broadcast addresses. Each network address contains or identifies host address and broadcast address to describe. So let's go to the IPv4 unicast, broadcast, and multicast. It's composed of static IP version 4 address assigned to a host. So this device can be assigned as an IP address either statically or dynamically. In networks, some devices require a fixed IP address. For instance, printers, servers, and network devices need an IP address that does not change. For this reason, these devices are typically assigned static IP addresses. So next one is the dynamic IP address, IPv4 address assignment to a host. Dynamic, in the most data networks, the largest population of hosts includes PC tables, tablets, smartphones, printers, and IP phones. It is also often the case that the user's population or your device change frequently. It would be impractical to statically assign IP version 4 address to each device. Therefore, these devices are assigned IP version 4 address dynamically using the Dynamic Host Configuration Protocol, or also known as the DHCP. So next one is the IP version 4 communication. A host successfully connected to a network can communicate with each other devices in one of three ways. Number one is the unicast, broadcast, and multicast. Unicast, the process sending packet from one host to an individual host. The next one is the process of sending packets from one host to all the hosts on the network. It is the broadcast. The next one is the multicast. The process of sending a packet from one host to a selected group of hosts, possibly in different networks. So unicast transmission is used for normal host-to-host communication in both a client and server and a peer-to-peer network. Unicast packets use the address of the destination devices, as the destination address can be routed through an inter-network. Next one is the broadcast transmission. Broadcast traffic is used to send packets to all hosts in the network using the broadcast address for the network. With the broadcast, the packet contains destination IP version 4 address with all the ones in the host portion. This means that all hosts on that local network broadcast domain will receive and look at the packets. Many network protocols such as DHCP use broadcast. When the host receives a packet sent to the network broadcast addresses, the host processes the packet as it would be packet addresses to its unicast address. Next one is the multicast transmission. Multicast transmission reduces the traffic by allowing a host to send a single packet to a selected set of hosts that subscribe to a multicast group. So this is the testing and verification. Ping testing the local stack. Ping is a testing utility that uses ICMP echo request and echo reply messages to test connectivity between host and ping. Works with the both IPv4 and IPv6 host. To test connectivity to another host on a network, an echo request is sent to the host addresses using the ping command. If the host at the specified address receives an echo request, it responds to the echo reply. As each echo reply is received, ping provides feedback on the time between when the request was sent and when the reply was received. This can be measured of a network performance. Next one is the ping testing connectivity to the local lab. You can also use ping to test the ability of a host to communicate with the local network. This is generally done by the pinging the PIP address and the gateway of the host. A ping to gateway indicates the host and the router interface serving as a gateway are both operational in the local network. Next one is the ping testing connectivity to remote. Ping can also be used to test the ability of a local host to communicate across the internetwork. The local host can ping an operational IP version for host of a remote network. If this ping is successful, the operation of a large piece of the internetwork can be verified. Successful ping across the internetwork confirms that communication on the local network the operation of the router serving as a gateway and the operation of all other routers might be in the path between the local network and the network of the remote host. Thus, the last one is the trace route, testing the path. Ping is used to test connectivity between two hosts, but does not provide information about the details of devices between the hosts. Trace route is a utility that generates a list of hops that were successfully reached along the path. This list can provide information, important verification, and troubleshooting information. If the data reaches the destination, then the traces list and the interface of the router in the path between the host. If the data fails at some hop along the way, the address of the last router that responds to the trace can provide indication of where the problem or security restrictions are found. So that's all guys for the chapter 7 IP addressing summary. Thank you.